All right, here we go. Special right triangles. What makes these triangles special? Well, we did Pythagorean theorem, correct? So we're actually going to keep doing that a little bit. And I am going to draw a triangle. Well, I'll tell you. I'm glad you asked. Oops, I forgot to change the writing thing. Let's change that to that and that to that. There we go. All right. And I'm going to try to make that the same length. So there you go. So I tried to make those the two legs, the same length. So what kind of a triangle would that be if these two sides are the same length? Because of the sides. Two sides are equal. What kind of triangle is it? Isosceles. Thank you.
Isosceles.
Do you guys remember anything I tried to teach you?
Nope.
Oh, my word. All right, here we go. So these two are equal to each other. So if they're equal to each other, and this is 90 degrees, tell me something about this. So if I told you that this and this were equal, you could tell me exactly how many degrees that angle is and how many degrees that angle is. What is it? 30, 30? So 30, 30 is 60. It's 45, that's right. Because if this is 90, everybody's listening, right? Everybody's up here. So if these two sides are equal to each other, it means the opposite angles are equal to each other. So this angle right here must equal this angle right here. If this is 90 degrees, the whole thing is 180. 180 minus 90 is 90. And these two are the same exact angle, and they add up to 90, so they both must be what? 45 degrees. So this is the special triangle, all right? It's called, I got to talk. Okay, you got to listen because we're running out of time already. So it's 45, 45, 90 triangle, all right? That's what we call it. It's a 45, 45, 90, all right? So it means it's a right triangle because you got the 90. It means these two sides are equal to each other. Or I'm sorry, yeah, these two sides are equal to each other. That means these two angles are equal to each other, or vice versa. Everybody good? What I want to do, I think we can handle this in an honors class. What I want to do is come up with a, I guess you could call it a formula, or just a, I don't know, what's a good word for it? A relationship, okay, between the legs and the hypotenuse, okay? Because this is a leg, this is a leg, this is the hypotenuse. Everybody with me? So I'm going to make this easy for us. What if I said that that side was 1? What would this side right here be? It'd be 1, okay? Let's find the hypotenuse. How would we do that? It's 2. You sure? Think. It's 1 squared plus 1 squared equals this, which is, we'll call it h for hypotenuse, okay? All right, everybody with me? So let's take a look. Or let's call it C. Remember we go A, B, and C? All right, so let's call it C. So 1 squared plus 1 squared equals what? C squared. Okay, this is 1, this is 1. You add them up, it's what? 2 equals, I'll tell you what, let's do this. You mind if I put the C over here?
C equals 2.
Does it?
C squared equals 2.
What's C equal to? Square root of 2. Why? Because I took the square root of this and the square root of that, okay? So C equals the square root of 2, okay? Let's do another thing real quick. I'm going to make it easy for you. Let's make this 2. Let's make this 2, all right? So watch. I'm running out of time. I can't take that. All right, let's everybody look. If this is 2 and this is 2, what do we have? 2 squared plus what? 2 squared equals, let's put C squared first. Is that all right? So C squared equals 2 squared, which is 4, plus 4, which is 8. Let's simplify it. This is a time where I definitely want to simplify it. So what's 8? It's 4 times 2, correct? So if I take the square root of 4 times 2, what's C equal to? It's 2 times the square root of 2. Very good. Okay? Now, watch this. We're going to do one more after this just to kind of get you thinking a little bit. So when the sides are 2, what's the hypotenuse? It's 2 times the square root of 2. What was it when it was 1? It was 1 times the square root of 2. Take a wild guess. If I make these sides 3, it was 1 times the square root of 2, which is the square root of 2, right? Okay. So, what's your guess? Say it, Hunter. Of 3? Of 2. Right. Let's see if it is, okay? That's our guess, all right? Only doing things 2 times is not enough to start a pattern, right? But if it happens the same way 3 times and then 4, 5, 6 times, then you definitely see a pattern. Okay, we're only going to go 3 though. All right, so let's do it real quick. So c squared is equal to what? 3 squared plus 3 squared. C squared equals, what's that? 9 plus 9, which is 18. So if you take the square root, what's 18? Isn't it 9 times 2? Let's don't do 6 times 3 because I can't take the square root of 6, right? I mean, it's true 6 times 3 is 18, but I wouldn't use that. I would use 9 times 2 because I know I can take the square root of 9. And what is that? It's 3 times the square root of 2. Check it out. So I think we've come up with a pattern, don't you? All right, so here's what we're going to say. In order to find the hypotenuse of a 45, 45, 90 triangle, all right, which means what's true about the sides? If it's 45, 45, what's true about both legs? They're equal to each other. That's right. Okay, so the hypotenuse is always going to be the square root of 2 times what? Yeah, what do we call them? We don't call them the sides. We call them the legs. That's it. So this is what you should memorize right here. Okay, so the hypotenuse is the square root of 2 times one of the legs. So let's do another one just using this. What if, give some funky number, let's say 17. What if that was 17, then what's this one? That's 17. What's the hypotenuse? 17 times the square root of 2. Or like I said earlier, some teachers say 17 root 2. I don't know, I just could never get into that. So I say square root. What do you think? It's pretty easy, isn't it? What if you went the other way? What if they told you... What if they told you... Again, let's just pick some weird number, like 19 times the square root of 2. What if they told you the hypotenuse, and they told you it was a 45, 45, 90 triangle, okay? What if they told you the hypotenuse, you want to find one of the legs? Then what would you do? What math would you do to solve the leg? To get leg by itself, you got to get rid of the square root of 2. What do you do? No? Nuh-uh. I want to get rid of this. I want to get rid of that whole number. No. Because then I'd have to square leg. I don't want to... I'd have to... Yeah, don't want to do that. Look, this is just being multiplied by the leg. How do I get rid of something that's being multiplied? Just divide it. That's right. I divide it by the square root of 2. Follow me? So this is one you don't really have to memorize. You could always figure this out. So how do I find the leg on a 45, 45, 90 triangle if I know the hypotenuse? I'm sorry. Yeah. If I know the hypotenuse, what would I do? I would take the hypotenuse and do what to it? Divide it by what? Square root of 2. So how would I find this right here? I would go 19 square root of 2 and divide it by what? Square root of 2. And what do I get? I get 19. What if it was this? Hang on just a second. I know the bell rang. What if I told you that this was, I don't know, 15? How would I find this leg? How would I find the leg? What did we just say? If I know the hypotenuse, how do I find the leg? I take the hypotenuse and I do what to it? Divide it by the square root of 2. So what would it be? It would be 15 what? Divided by the square root of 2. And what would this be? 15 over square root of 2. Now, I'm not going to get into it because the bell rang. You never want to have a square root in the denominator, okay? There's a way to get rid of it. It's called rationalizing the denominator. Remind me tomorrow. Somebody put that in their notes. Remind me tomorrow to show you how to simplify that, all right? Everybody good? All right. So that was the one special triangle. We're going to do another special triangle tomorrow, and that's a 30, what do you think? 60, 90 triangle. That's right. So we're going to do that tomorrow.